Good morning, students. So last class we discussed the Coulomb's law. So now we'll extend that class, that is Coulomb's law in vector form, how we can write, that will be discussed it. Now Coulomb's law in vector form. Let us take the coordinate system like this. Then let us assume here at a point A, this is the charge Q1, this is the position vector is R1 bar, and at this point B, here the charge Q2, this is the position vector R2 bar. So these are the R1 bar and R2 bar, these are the position vectors of Q1 and Q2. Then Q1 will exert force on the Q2, Q2 will exert force on the Q1. Now if you line join this one here like this, then from the triangle of vectors this will be R21 bar, that is R21 bar equal to R2 bar minus R1 bar. Then the force acting on Q2 charge by Q1, that is we can take it as a F21, that is force acting on the second charge due to first one, that is F21 bar. So F21 bar we can write as a 1 upon 4 pi epsilon naught Q1 Q2 by, what is the separation between them is R21 magnitude we are taking, R21 square into this direction we can write as a unit vector R21 cap. So here R21 is the direction unit vector which represents this direction, that is away from the Q2. Here R21 cap we can also write as a, so unit vector means it is the ratio of its magnitude by its vector here. So ratio of its vector is R21 bar by its magnitude is R21. Then we can write it is R21 bar by R21, that we substitute here. So F21 bar equal to 1 upon 4 pi epsilon naught Q1 Q2 by here R21 cube into R21 bar. So like this also we can write, and it is away from Q2, that is along AB. It is along AB. Same way, the force experienced by Q1 due to Q2 is also away from Q1, that is we can show like this here. Same, this is the position vector of first charge Q1, and this is the position vector at point B, this is the second charge Q2. Now this is the line joining of it, this is line joining of it is R12 bar. So here R12 bar equal to R1 bar minus R2 bar. Then this is the force acting on 1 due to 2, this is F12 bar. Then F12 bar is nothing but 1 upon 4 pi epsilon naught into Q1 Q2 by R12 square into R12 cap. So this is a unit vector that represents along the BA direction. Now as same like this, you can also write that R12 cap equal to R12 bar by its magnitude. So R12 bar by its magnitude, in the sense you can write R12. Then if you substitute in this, F12 bar is nothing but 1 upon 4 pi epsilon naught into Q1 Q2 by R12 cube into R12 bar. Its direction is along BA. You can understand that the magnitude of F12 and as well as the magnitude of F21 both are equal, but the directions are opposite. So F12 bar is nothing but minus of F21 bar. This is the thing you can understand by Coulomb's line vector form. So when they ask you write the Coulomb's line vector form means you can represent this F12 force, or else means force acting on 2 due to 1. Also you can write this force acting on 1 due to 2, and these are so mutually one over the another the forces. So but they are magnitude wise same, but the direction wise it is different. Now we can go for the next one. So same force between multiple charges, that is the principle of superposition. Then we can go for the force between multiple charges. Force between multiple charges, that is you can also write as a principle of superposition. Let us take one charge which is kept at the origin. So we are taking that here one charge Q is there. Then surrounding it we have the charges like here we have another charge Q1. The line joining from this charge O2 at this point A. This line joining vector is R1 bar. Then this will experience force that is away from it. It is F1 bar. Similarly here one more at point B, here charge Q2 is present. This line joining vector is R2 bar, and this force is F2. Same way here we have another at position C, here at R3 bar unit vector. Here this is the position vector of charge Q3, which is at a distance R3, and this force experience force is F3 bar, and so on. We have many charges like this we have at somewhere Qn charge is there. Its position vector is Rn bar. Then its force direction is away from it, and it's Fn bar. Now the total force here, these the things and all will take it in the vacuum. So you know in vacuum means the dielectric constant is 1. So in this the force acting on Q due to charge Q1 and force acting on Q due to charge Q2, and all these are F1, F2, F3 and so on. So similarly the net forcing acting on the charge Q, the net forcing acting on the charge Q, we can take it as the factorial sum of all these forces. So net forcing here F1 bar means force acting on the Q due to charge Q1, that is 1 upon 4 pi epsilon naught into, as we discussed in the vector form of Coulomb's law, Q1 by R1 square into R1 cap. Similarly F2 bar equal to 1 upon 4 pi epsilon naught into Q2 by R2 square into R2 cap, and so on. If you write Fn bar equal to 1 upon 4 pi epsilon naught into Qn by Rn square into Rn cap. Now the net force acting on Q is net force acting on Q is given by, you can write F bar equal to the vectorial sum of all these forces, F1 bar plus F2 bar plus F3 bar and so on, F1 bar, that is equal to, we can write these are the added vectorially. So for negative charges direction also gets reversed. For positive charges direction is same, negative charges the direction will be reversed. Suppose if it is Q1 is positive charge, it is away from it, but if it is Q1 is negative charge, means it's towards it, like that. Based on the polarity of charge, the force direction is reverses. Then this is the vector sum of all these forces which is experienced by the charge Q present at the origin. So this is the force between multiple charges. Then we'll go for the few of the some objective points in this. So few of the objective points now will be discussed it here on basis of this Coulomb's law. Objective points. Here we discuss it clearly that in vacuum Q1, Q2 charges are present if they are separated by distance r. Force between them is F is equals to 1 upon 4 pi epsilon naught Q1 Q2 by r square you are writing. So this is in vacuum. So in medium, in the sense in any medium Q1, and we are maintaining the same separation Q2, then it's dielectric constant K, that is R. We can also write epsilon R. F is equals to, we are writing, this is F in vacuum, this is F in medium. There is 1 by 4 pi epsilon we are writing here. Epsilon in the sense the permittivity of the medium Q1 Q2 by R square. In this epsilon is nothing but epsilon naught epsilon R. You know, epsilon R relative permittivity is the permittivity of the medium to the permittivity of free space, or permittivity of the medium is equals to permittivity of free space into relative permeability, or else you can also write this as a K epsilon naught. That's why in place of epsilon you can write K epsilon naught. Therefore force in a medium is equal to 1 upon 4 pi epsilon naught into 1 by K into Q1 Q2 by R square. Therefore you can write F medium is equals to 1 by K into 1 upon 4 pi epsilon naught Q1 Q2 by R square. So this is the point. You can understand that when it is the medium is there, so we should take that that is 1 by epsilon naught times the 1 by K times the F what vacuum. Then if two different mediums are there, you can observe that if two different mediums are there, if Q1 and Q2 are placed in two different mediums having same separation, same separation in the sense that is R is same, and Q1 and Q2 same. But what is the difference here? A different medium. Different medium means different dielectric constants are there. So different medium. And according to that formula we have, then we can say that what is the ratio of forces. Then ratio of forces means we know here F is equals to 1 upon K into 4 pi epsilon naught Q1 Q2 by R square. Here Q1 Q2 is not changing and distance also not changing. This is constant. Then only medium to medium K is going to be changed, and K going to be changed means force is going to be changed. Then these two are how you can relate it is F inversely proportional to 1 by K. Therefore the ratio of forces F1 by F2 in two different mediums is equals to K2 by K1. So this is the thing you can understand that if two different mediums are there, the ratio of forces is K2 by K1. Next we can understand that if distance, if same medium is there, if Q1 and Q2 are placed in same medium and distance, how it is the same medium in the sense you can write 1 upon 4 pi epsilon naught into 1 by K Q1 Q2 by R square. If distance changes, means medium, same medium, so constant K, same charges, this is constant. Then force is inversely proportional to r square. Force inversely proportional to r square in the sense we can write F1 by F2 equal to R2 by R1 whole square. Or let us suppose example, if Q1 and Q2 are two charges, so experiences force, some we say 8 newtons. If distance doubled, what is the new force? So what the distance they are making double, so same medium. If they mentioned the same medium, if they not mention any about medium means they are maintaining in the same medium. So here distance is double. Distance double in the sense you can understand the force and distance how they related to each other. Here is F1 by F2 equal to R2 by R1 whole square. Here F1 they are experiencing initially 8 newtons, so 8 newtons by F2, and R2, so R1 and R2 they make it double. Distance double means R2 is 2 R1 whole square. Then these two cancelled, then is F2 equal to 8 by 2 square means 4, that is 2 Newton. So force is what happened, new force is 2 Newtons it will be. Next we can say that if dielectric medium is present, we are telling the force reduces by dielectric constant times if Q1, Q2 are the two charges here and separation is R. Completely this separation, if it is filled with the dielectric constant K, then what about the force? We are writing F is equals to 1 by K into 1 upon 4 pi epsilon naught Q1 Q2 by R square. So completely it is placed in the dielectric medium between the space. But already we discussed one thing, if two different dielectric mediums are there, force should be remains the same. We're taking the point here, if two mediums here, so Q1 here Q2, separation is R, medium is K1, distance is R1, then the force is F. Now same way here Q2, Q1, Q2 charge, the medium is K2, distance is R2, but force should be same. So you understand clearly that two different mediums, K1 one medium, K2 another medium, dielectric constants, charges Q1 and Q2 in both them. So different medium means force changes. Force should not change in the sense what we have to change it here, distances we are changing. Then how we can relate these two means then we can understand. So here force constant, because force remains the same, this is constant. Next Q1 Q2 also not changing, so this is constant, and K changing, and 1 upon 4 pi epsilon naught is a constant. So what is changing here is distance as well as the dielectric constant. Distance and as well as the dielectric constant, K r square equal to constant. Therefore we can write K r square is equals to what? Constant. So K r square is a constant based on this because two different mediums, charges are same and force should also be same, means distance should be changed. Then we can say K r square is constant. So based on this, for these two different mediums, we can write as a, so for these two different mediums we can write as K r square is constant in the sense k1 r1 square is equals to k2 r2 square. So this is the relation you can understand. First, if k1 is a vacuum, that is 1, and k2 is a medium, some other medium, that is you take as a k, then r1 vacuum distance, no, so we are taking as a vacuum distance r equal to r naught and r2 equal to r. Therefore we can write as a 1 r naught square is equals to what, k r square. So we can write r naught is equals to root k times the r. This is the relation is important. What is this relation is? The effective distance in vacuum is equals to root k times the distance in, then it means the effective distance in medium. Or else you can also write r equal to r naught by root k. Means the effective distance in medium is nothing but vacuum distance by root k. So this is the thing you can understand. Vacuum effective distance in vacuum is equals to root k times the distance in medium. Okay, now we'll take the example here where it is useful to us. Here charge q1, charge q2 is the two charges present, and separation between them is r, and partially here we have a part is a dielectric constant is present, not completely filling, only what, x part only dielectric medium is there. Remaining r minus x part is vacuum is present. So partially we are filling the dielectric medium. So r minus x distance vacuum and x distance medium. Then what is the force between them? If completely space filled with dielectric constant, we write force is equals to force in vacuum by k. But partially filled case, how to write here is, so force is equals to, so first we understand that x in vacuum means that is we should be write equivalent in x distance in medium, and this x distance in medium is equivalent to in vacuum how much. So we have the effective distance in vacuum is root k times the distance in medium. Therefore effective distance in vacuum, that is equal to how much is there, root k times the distance in medium. So vacuum, original vacuum distance is r minus x. This part is in medium. Again this equivalent distance in vacuum is root ks. Then if you take this r minus x and plus root kx, now the distance is completely is in vacuum it becomes. Then the force we can write as a F is equals to 1 upon 4 pi epsilon naught q1 q2 by, we are taking effective distance in vacuum, even some part is present, that equivalent distance in vacuum we took here root kx, then total distance is r minus x. Here we are not writing any k. Why? Because already we are taking the entire distance, effective distance in vacuum. So this is so no need to take the k because we are taking the effective distance in vacuum itself. Then root k times the x distance square. This is the force in what, effective distance, force in the totally we took converted the medium distance also into vacuum distance. So this is force in vacuum case. Or else you can also write according to this effective distance in medium is equals to effective distance in vacuum by root k. If you write like that, effective distance in medium, that is nothing but is equal to medium, how much is there, x. So medium how much is there here, x, effective distance in medium is nothing but we can write as x, and the remaining how much is there, r minus x is there. Then effective distance, that one in medium means so effective distance in medium means we can write as a remaining vacuum distance. Earlier here medium distance converted into vacuum. Now vacuum distance r minus x is converting into medium. So effective distance in medium is r minus x by root k. Why? Because medium effective distance in medium equal to vacuum distance by root k. So we took here. Now completely the force is becoming in medium is nothing but F medium equal to 1 upon, here we have to write k. Why? Because we are taking effective distance in medium. So 4 pi epsilon naught into q1 q2 by what, x plus r minus x by root over k whole square. This is the force. Like this if you partially filled, so either you can take either this formula, so completely converting medium distance also into vacuum, or else you vacuum distance you have to convert into medium effective distance in medium, you can take this formula. In both the formulas if you use it, you will get the same result. This is the thing you can understand well.